Hello, this is Jeffrey Carmen with Strategic Marketing Simulator 1.0 Introductory Video. Team members include Javier Andrial and myself. Product owner is Joseph Seeley. Project mentor is Masood Majadi. Problem definition. University instructors need a means for having their students run simulations of hotel sales market to show the impact that different marketing budget allocations will have on that market. These allocations are in the form of marketing personnel, advertising, and promotions, along with the type of hotel and the location of the hotel chosen. The way a student utilizes their budget will ultimately affect the market. By the same token, these students need a means for interpreting the effects of budget allocations that other students have made in the same market. Finally, instructors need a way to track these results over varying intervals of time. Project management. This project was accomplished over 8 sprints. Sprint 0. We collected the user stories from the product owner, Joseph Seeley. We built a backlog and mingle of all the user stories that needed to be completed, and we also created a website mock-up of what the final product might look like. For Sprint 1, we set up the database subsystem, installed the LAMP server, and we also completed the user account creation and user login user stories. For Sprint 2, user stories completed were forget my password, password recovery, user homepage, and for Sprint 3, admin manage page show, admin account creation, admin bot creation, join group, and create group. Sprint 4, admin strategic decisions, student strategic decisions, admin login, and user view news. For Sprint 5, account management, market share graph, leaderboard, user commit and comment, and admin game page functionality. Sprint 6, end of period algorithm, professor feedback, professor portfolio, commit and comment repository. Sprint 7, bot play, student reporting, intro videos, and for Sprint 8, final presentation week prep. Requirements, implemented user stories. User story 711, deactivate users. 776, student create group. 704, admin login. 769, student join group. 667, forgot my password. 669, user login. User story 666, account creation. 718, manage page. 709, admin news. 685, admin games page. 712, user commit and comment. User story 684, bot creation. 683, admin account creation. 681, admin users page. 680, admin home. 679, user view news. User story 678, user strategic decisions. 810, admin strategic decisions. 800, admin news management. 708, user scorecard. 676, user home. User story 672, market share graph. User story 671, user leaderboard. 842, professor feedback. 841, professor portfolio. 840, commit repository. 847, end of period algorithm. User story 856, bot play. 710, user navigation bar. 853, student reporting page. Requirements, use cases, use case diagrams. This use case diagram is that of the strategic decisions page. The actor here is the student. The student can select from either market segment, average daily news, advertising, marketing research, and marketing personnel. Once the student has selected all of the decisions for a period, they select decisions by clicking the Select Decisions button. Requirements, use cases, use case diagrams. Strategic decisions management. The actor here is an admin. The admin has a choice to change ATO allocations impact, marketing research impact, advertising, marketing personnel. For each of these, they have the decision to make to change both the price and the impact of the market. Once they have selected all of these, they can commit these to the database model by selecting the button Select Decision. Here we have the news article use case diagram. Two actors here are the admin and the student. The admin chooses a game, chooses a period for the news article, writes an article, and then saves the article to the database with the impact for hotel location and hotel type. The student actor in this diagram can view news. Account management change password sequence diagram. The actor here is a user. The user at the account management view presses the My Account link. The account controller is then called with Create Page. The account controller requests the user information with the email address. When the user is returned, the account controller displays the message for the view. Select Change Password. Change Password function call from account management is made to account controller. The display change passwords page is returned. The student then enters a current password and the new password. The account management view sends a function called update password with the current password and new password to the account controller. The account controller calls the database model GenPass, which creates a 256-bit hash for the password to ensure that the information is secure in the database. Now here we have two alternatives. One alternative, the incorrect current password message is displayed, and the other alternative, the correct password makes a success message. End of period sequence diagram. Here the actor is a student. The student visits the home page. The home page displays the end of period trigger. The game controller gets all impact for the game period from the period controller. Here we have a loop with the database model wherein each group in the game has to call their impact for the game, which is returned to the period controller in an array. That array is then returned to the game controller for later use. The game controller then calls the get rooms for the game and the period from the period controller, and the period controller calls the database model to get the rooms, which are then pushed to an array, which are ultimately returned to the game controller. So here we have a loop. We have the market share algorithm. For each impact of the group, the algorithm specified is applied for each of those groups. The same is true for revenue. For each group in the game, the get revenue function is called. Once all this information is apparent, then it is then stored in the database model for the next period. Professor downloads a report. Here the actor is an admin. He selects the reporting tab. The reporting page view calls a function choose game to the report controller. The report controller gets all the games from the database model, and the database model returns an array of all the game entities. The table is displayed for the admin with all games. The admin selects a game. The reporting page view makes a call to the report controller function choose period game ID. The report controller then gets the game ID using the game ID provided from the model base, from the database model. The game entity is returned. A table of the period is returned. The admin selects the period, and a report is generated for that game period. System design, system decomposition. The system was designed using the model view controller design pattern, wherein there are client-side views written in HTML and JavaScript, controllers on the server side which are written in PHP, which control the flow of information between the models and make calculations based on the user inputs, and models which are used to store and access data in a meaningful way. System design, system deployment. For this project, we were given an Ubuntu 14.04.3 LTS server. On that server, we installed Apache 2 web server, PHP, MariaDB, MySQL database for the models. The minimum requirement for this Ubuntu server is 700 MHz processor, 512 megabytes of RAM, and 5 gigabytes of hard drive space. For the client side, a PC or Mac running Internet Explorer, Firefox, Chrome, Safari, or Opera web browsers will be sufficient. System design, persistent data design. Data is preserved in a fully normalized MariaDB MySQL database. As previously discussed, the model view controller, we have views on the client side, controllers and models on the server side. System design, security, privacy. Log in with an email and password. Passwords are hashed using a 256-bit hash to secure the information in the database. Sessions are cleared upon leaving the system. Detailed design minimal class diagram for the PDF generate report. Here we have a game object, hotel object, and market share. For each game, there are different news parameters, and for each hotel, there are different comments for different periods. Here we have a minimal class diagram for the system in general. We have a game and a period where you find that there is an association with a many-to-one association between period and game, wherein any game can have many periods. Also, this is true for the market share. For any game, there are multiple market shares, which are broken down by period. And for every market share, there are multiple impacts. Now, impact is there's an association, a one-to-many between impact and news. And news, again, is affected by location and market segment. The impact affects strategic marketing in a one-to-many association, and the same is true with groups and users. Period state machine. This is the state machine for the period. The current period is the starting point for the state machine. The trigger is a check date check at the beginning of each view of the home page. Now, the guard here is if the current date is greater than the end of period date in the model. If that happens, then a call to the end of period algorithm is made, and the next period is the next phase in the state machine. Detailed design end of period algorithm. The end of period algorithm is the algorithm which does all the calculations to determine both market share and the revenue for each group for a period. So we let phi sub j be the strategic decision selected by group G sub I. Let mu be the news impact by location. We'll let omega be the news impact by market segment, where mu and omega are within the range of 0.7 and 1.3, and phi is within the range of 1 and 1.3. We also let gamma be a random modifier for phi, mu, and omega, where gamma is between 0.95 and 1.05. The reason why this was done with regard to gamma is that we want to make sure that for any two groups having the exact same selected decisions, their outcome would not be the same. This was used as a way to handle the customer aspect where regardless of the marketing decisions made, customers are going to make decisions based on their own situations and events in their life. So we'll also let R be the total number of rooms available in the market, and we let I sub j be the game impact for a period I defined by I sub j equals the product of phi times gamma, all multiplied by mu omega. We'll let theta be the total number of rooms actually sold, defined by the summation of the impact for each group divided by the number of groups multiplied by the total number of rooms in the market, further modified by gamma minus 0.05. That's where n is the number of groups in the participating in the game. We also let beta be the market share for a period as a collection of beta sub I, the market share for each group defined by the sorting of alpha times theta, which is the average rate for a group multiplied by the total number of rooms actually sold divided by the summation of all the average rates for all the groups. You take that in a collection and you place them in order, and then for each market share you do a reverse sort wherein the first group in the list takes the market share in the last group in the list. The reason why we did this is to make sure that as the average rate selected increases, the number of rooms that they actually sell decreases and vice versa. So we'll go ahead here and we'll let rho be a modification on revenue for the group for a given period. This is for OTA allocations. OTA allocations are those like Expedia.com or hotels.com, which are basically third-party vendors, such that rho equals 0.7. So we have delta sub j, which equals the floor of the average rate of j multiplied by the market share of a group j subtracted by epsilon, where epsilon is the number of rooms allocated for OTA. Now, this formula also holds if no OTA was selected, and that becomes delta sub j equals the floor of alpha sub j times beta sub j times rho. So for our test cases, we have both a sunny day and a rainy day. Here's an example of a sunny day for end of period algorithm. The description here is that a game controller test for the period has ended. The game controller calls date check function, which checks the database model for the end of period date time. If the current date time is greater than the end of period date time, then the algorithm is called. So there were 6 steps for this sunny day test. The first step is to create a game controller object. The second step is to get the current date time. The third step is to select the game. And the fourth step is to select the period. Fifth step is to select the period time. Now for the sixth and final step, we assert that the current time will be greater than the period time. This passed because the model that we were working with showed that the period time was in fact less than the current time. Here is a rainy day for end of period for the exact same test case. Here for the test steps, we set up for step 1 the object for a game controller. We get the current date time. We get the game equals 3. And here we select period equals 50, which is higher than the highest period the model has. So period time equals the object check time. Now here we assert that it would be greater, the current date would be greater than the period time, and this fails. Automated test scripts. Now here you see that we have an at covers A. Basically we had to create an XML file which basically parses these scripts in a meaningful way so that we have an output of the test cases run. So this is an example of a test script for the function update game period. Here we create a database object. We create a p start, which is the date of the period start. We have the p end, which is the date of the period end. We select the game 3, and we assert that given the update to that end and beginning period, the database model will return pass. Here we have another one for commit. Here we create comments, and this string saying we decided to choose more personnel for this period to try to increase our hotel sales. Email equals under18 FIU. We create an object for period controller, and we assert that given the call to that object with the comments in the email, that the model would return pass. This is a demonstration of Strategic Marketing Simulator login, student homepage, strategic decisions, and commit and comment. So first we log into the system using the provided username and password. The system automatically navigates the user to their homepage. In the homepage, they can see scorecard, which indicates the period in progress, the group information, the status, market share table, and market share graph. Also, in the selected decisions section, they can see what decisions they've already selected for this period. In the leaderboard section, it shows you all the groups in the game and their progress by revenue in descending order, along with a bar graph of visual aid. So, if we select the strategic decisions link on the top of the nav bar, we can select new decisions for this period. I will place the room rate at $100. I will select a couple random advertising. I will pick 2 entry-level personnel and 1 manager and training personnel. And I will also select 200 rooms for OTA allocations and select decisions. So the system will automatically navigate to the home page where you can see that these decisions have been updated. Now, when the student group has decided that they're happy with the decisions that they've made, they can choose to commit those decisions for the period. When they click on the commit period button, they are asked here to put in the reasons for why they selected these decisions. So if I click on the commit comments button, you will see that the decisions were committed for this period, and while the period is still commencing, they can go back and change their reasons at any time. Now I will show you a demonstration of some of the admin pages of the system. First, we log in as the administrative user. We're automatically navigated to the admin home, where the admin can choose to add administrative users, add bot users, view all games, view all users. Administrator can also do reporting. Selecting the reporting from the navigation bar on the top, the administrator can select reports, select the game, choose the game, and select a period. By choosing this period, a report is automatically generated for all the groups in that period. It is a PDF report that can be used for later viewing.